we should put them in those brackets. Let's try. IP is 127.0.0.1 for local host.
127.0.
Local host.
Wait, these are separate lines, right? Not the same one.
Yeah. So you can comment out that first NC minus L one. Try that echo thing. Let's see what happens.
Syntax. Maybe.
No, I think it could.
Oh.
Double quote.
Oh no, it's this NC thing.
Syntax.
Doesn't work.
Oh, maybe you should try it in the bash terminal.
Oh, this is running it as Python, right?
Yeah.
Yeah.
I remember when I changed the kernel to the bash, they don't understand it.
Create a new one. Keep it like try a new kernel. Another line, I mean.
Sorry, say that again?
Like in a different line. Yeah, try that. Same there.
Is there another flag for this? Oh, actually, no, I'm saying this is on there.
There's another syntax you can use. Yeah, I'm not sure if we're supposed to put the IP in the ports between those. C minus U minus Q. No. So try NC. No, without those. Yeah.
These.
Yeah, we don't need those. Try that. No, keep the last one. The last one we need.
Oh, okay.
Not the comma. I don't think we had a comma. Yeah. Try that. Doesn't like it. Try NC minus U. Space. Yep. This thing doesn't like us at all.
When I ran it, it said port number invalid.
That's a different error.
Yeah.
Port number invalid 9999.
Okay, that did port number invalid as well. So it says /dev/FD63. So if I try to, yeah, I don't know what's doing that.
Why?
All right. Well, for the interest of time, you can figure that out, I'm sure, guys, once we're done. But let's go back to the notebook.
Okay.
We'll go through the remaining points, like concepts and contents at least. But let's assume it worked. Okay. We understand what's supposed to happen, right?
Yeah.
Yeah.
Okay. So let's go back to Spark Streaming. And then when we're done, I'll let you guys explore, and then we can see where things are heading. So we finished that part. Go down. Finish that part. We assume it's going to work.
Let me just restart the kernel.
Only one streaming context may be stored in this JVM because this is a virtual machine. It's saying we had multi-threading on, remember?
Oh, yeah.
So this does not support multi-threading. This multi-processing CPU count, it's not supported in a virtual machine. That's could be actually what's causing this error. Could be one of the reasons. But anyways, let's proceed for now. And then we can come back and remove that and test and play around with the Linux command. At least we understand what's going on. Okay. So let's scroll down. Down, 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 down.
Okay, now it's just gone.
Down, down, down. Now this will give an error, number one. So back to analyze. What it's saying is, let's analyze our results. This infographic will help us clear the confusion. And I do not see an infographic. As one can see, operations are done on the batch of gathered data, not on the whole data set. So what this is saying is the word count will work on every batch we're sending, right? Every line of text we're sending, basically. Okay. It won't do it on the entire data set. So it won't store the historical data. It won't store the historical data. It's only on the batch that's being sent at the time. And streams will be automatically cleared. If we want the data to be stored, we should persist the results to this periodically. So when we work in memory, when the data is coming in batches, once we see it, it could disappear, right? What it's saying here is if we want to persist means permanent storage. So if we want to permanently store the data, we need to save it to a disk periodically. That's what it's saying, because the streams will automatically be cleared, right? They have a specific memory allocation, and it's like garbage collection, and when we do coding in variables, they'll be cleared automatically. All right. So let's move on. Now we're getting into some of the transformations that Spark Streaming supports. So one of them is called update the state by key. It's a function which allows us to keep one state and update it continuously with values coming in from a stream, and takes two arguments, new and accumulated. So this is an example. Can you scroll down, please, a little bit still on the screen? Yeah. So in this example, it's a function called update function. What is it doing? Who can tell me what it's doing? I think it's should be self-evident.
It adds both of those variables if one of them doesn't store anything.
Yeah. So if running count is none, so this is like a counter. If it's none, set it to 0. So that's our initial. And then return the sum of the new value and the previous or the current running count, right? So this is accumulating the count of words, and it's applied on a per key value, so for key value pairs. So this is basically counting the words in real time, right?
Yeah.
Okay. You can try to run it, but I'm not sure if, all right, it works. So we have another type of transformation. So update state rather by key is one function. Window operations are another type of functions. They allow us to apply operation over a sliding window of data. So what's the sliding window? Anybody have an idea?
Is that like multiple batches?
Very close, yes. It's a sliding window. It's kind of a terminology in Spark Streaming. It's like a view or a window that you can look at data as it's passing by, basically. Continuously, the window is the view that you have on a specific batch of the data, right? So what these operations do, they slide over the D streams, RDDs. RDDs within the window are combined via operation. These combined values create a new D stream. So what it's saying basically is you can use D stream to create a new D stream, right? It's a type of data transformation. An example function could be reduced by key and window, reduced by window, count by value and window. So these are just different operations we have available to run on data as it is in motion. Does that make sense?
Yeah.
Yeah.
So these tools, so Spark Streaming is a data processing framework. It gives us some tools So analyze and process data as it's moving, real-time data as it's moving. We have more powerful tools that can be used on the data once it is stored in a permanent storage location, like S3 Cloud or Hadoop HDFS. We can do fancy ETL work, right? These type of operations are simple, something we can do on the fly, okay?
Okay.
Other type of operations are joins. I think we all know what joins is. Streams can be joined with other streams, and data frames we have in memory. So you can use something called a join stream that we can use to join two streams, similar how we join, two tables in SQL, if you remember.
Yeah.
Or we can use them to join data frames as well that we have in memory. So you can have that RDD or data frame we created, unique keyword count. You can use that, join it to a stream of data and create a new D stream. Okay. So this is just an example. There's nothing there to run because we don't have streams coming. That's why it's just 3 dots. It's it's a symbolic example, right? Yeah. If we have a stream 1 coming in and a stream 2 coming in, you can join them in the following format. Join stream equals stream 1 dot join stream 2. The same type of joins are supported as in the case of PySpark SQL. So it's similar to SQL join. One can also join streams with data frame objects via transform. Notice one can change data set, we're joining again. So if we have a data frame here called dataset, we would join it as follows. Join stream equals window stream dot transform lambda RDD dot join data. So this is just the syntax to join a data stream, D stream, with a data frame.
Okay.
Right? It's just demonstrating some of the features we have. Does that make sense so far?
Yeah. About this number 20, is that referring to the number of RDDs that you see in the window?
I believe that would be the time. The time? Window length, yes. So that's the length of time the window should be consuming or ingesting the data. Because again, keep in mind, like a data stream, D stream is continuous, right?
Yeah.
So what you're telling it is, just wait for 20 seconds. I believe this is in seconds. Then that batch of data, store it in a windowed stream RDD.
Okay.
Yeah. If that's 50, it'll be 50 seconds of data. Like, let's say every second we get 1 word, this would store 20 words, correct?
Yeah.
If it's 50 seconds, it will store 50 words, etc.
Yeah.
And then the join stream, you would join those words to an RDD we have or data frame that we have. That's basically what the join operation does.
Okay.
Okay, let's scroll down. Saving streams. One can also save data after necessary transformations were applied. I think we need a space after. I'll make a note of that. But basically, why we need to save? It's because these streams are coming and being processed in Spark's memory, right? In RAM.
Yeah.
What happens to a computer, guys, what happens to the RAM if we switch off the computer?
This is all its memory.
Loses the memory. So if you restart, will it be there?
No.
No. That's why if the data you're getting is important, we should save it. Right?
Through persist.
Through persist. Correct. And here, the way to do that is they give us some operations we can use. So 2 most common ones supported by the Python API are save as text file. So each RDD is saved in string format to a text file. And we can use for each RDD function. It's a generic function applying transformations. It can also be used for saving specific parts of the data. And it's giving an example. So function send partition connection, it just initiates the connection pool for every record in the iteration. Connection.send the record. Connection, and then the bottom command is the one we're interested in, dstream.forEach RDD. Lambda functions, RDD, for each partition, send partition. So this should be used to store data and save it. Can we scroll down, please?
So this part is telling the location of where to store it, or
this is the function name, actually.
I'm confused on what this function is supposed to be doing a bit.
So this is just an example, an example of for each like function could be sending partitions of data to another system. So this is a function called send partition, right?
Yeah.
We're defining a connection somewhere, right? Connection equals connection pool dot get connection.
Yeah.
And for every record, send it to that connection. So we can assume this connection points to an S3 bucket, for example, Amazon Cloud.
So connection pool is just a variable?
Yep. Connection equals connection pool dot get connection. What it's saying here is connection pool is a static, lazily initialized pool of connections.
Okay.
So
Okay.
it's not a full command. It's, ideally, we'd have this already defined with the proper connections, right? It's just giving an example of how the function would look like.
Okay.
All right, let's scroll down. I think we're almost near the end. So let's also see the code snippet below, which shows how one can mix PySpark SQL streams. Can you tell what this code does? Explain the lines. So let's initiate a global instance. So this is a properly set up connection now. Yeah. So definition get Spark instance, if Spark connection minus global, return global Spark connection instance. Data frame operation, words equals dstream of strings. Function process, time RDD, print, let's try Spark functions. All right, so this is just an example again. It won't fully run if you run it. So it's asking, can you tell what this code does and explain the lines? What is it doing, guys?
And so this is just function for being able to create a Spark session.
Yes.
Then this just some sort of input dstream of strings.
Right.
This is the part that I'm trying to figure out.
Yep.
Find process time RDD.
It's a function called process. It takes two inputs. Time and
So is that the
RDD.
time that it's coming and was
Right.
is that taking it for every RDD that comes through basically?
Looks like it, yeah.
Mm.
So raw RDDs, RDD.map. Sorry?
Time is telling us the time at which each RDD has come in.
Mm-hmm.
And a singleton instance of Spark session. RDD.context.
So this is just standard Spark get session, yeah, context. It's just
Oh yeah, you have to get the configuration. Okay.
And then we convert the RDD string to rows to data frame. So what it's doing, it's transforming a Spark RDD into a type data frame.
Okay.
That's these next two lines. Then it's creating a temporary view. Data frame is a Spark SQL terminology, very similar to pandas. You remember the data frames in pandas?
Yeah.
Yeah.
So when we have it in a data frame, you can do SQL-like operations. So one of them is create temp view. Do you remember what a view was in the world of SQL?
I'm not familiar with it.
Basically a table. Is it a table similar to a table?
It's very similar to a table, correct? It's a temporary, basically, table. We can think of it that way. A view is a temporary table. It's a logical construction or a construct. Basically, it is what the meaning of the word is. It's a view. It's just showing you a view on an actual table from a different perspective, but it does not create a physical new table. So it does not need additional disk space, for example, right? It's just temporary as long as the application is running. Once the application completes, this table will be dropped from memory, okay? So what it's doing is creating a temporary words view or temporary view called words. And then we do something with it. This something is the next couple of lines. It is doing a word count using SQL commands, right?
Yeah.
When you say spark.sql, you can type any SQL commands we want. So it's creating a new data frame called word count data frame. And it's select words, count star, call that column total from words, which is the view we created in the previous line, and group by word. So what is that doing? Who can tell me?
As select word, the count size total.
Sorry, I was muted. But it's grouping the words by the unique word basically and counting how many there are in each one.
Exactly. So if we have like hello, hello twice, you'd have the word hello and the count would be 2.
2, yeah.
Okay.
If we had hello, hello world, you'll have hello with count 2 and world with count 1.
Or however many there are.
You got it. And then the next command is just to show. Show is basically print in data frame world. Okay. And then it's a try pass. So we finish that part. And then words.forEach RDD process. What this is saying is for each RDD in words, run the function process. Yeah. We have words, which is the stream of strings. So on every one of those words, or every rather RDD, run that process, run that function.
Yeah.
Make sense?
Yeah.
Kind of?
Yeah.
Okay. If we run it, we'll get errors because it's just an example, right? It's not a full, we don't have actual input. Okay, let's move on, gentlemen. We're almost at the end of the notebook. So persist and D streams. From the previous lesson, we learned about persistence and what it does. Using the persist method on a D stream will automatically persist every RDD of that D stream in memory. Things to note. We run multiple operations on the stream. By default, data from sources are replicated on 2 nodes. For some operations, this is done automatically. We'll compute multiple RDDs. So basically, this is just saying, we can save using this method important RDDs, and there are some configurations we can tweak. Yeah? Checkpointing, another concept to know. It's streaming services, they run 24/7. So Spark gives us something called checkpoints in order to be resistant to faulty nodes, Java virtual machine crashes, etc. Who can tell me what checkpointing is in general? Do you remember? Ishtiyaq?
No.
Tadzwa?
Is it just like making a save at a certain certain point in the data stream?
Well, checkpointing in general, yes. It's basically making like a save or like a commit we have in Git, right? So checkpointing, it's for fault tolerance. In case of failure, you can recover the last checkpoint. It's kind of like snapshots, yeah?
Okay.
So checkpointing has 2 types in the Spark streaming world. Metadata checkpointing, which saves the information defining the computation or the steps we have to take. Examples are these stream operations, configuration, on-premises batches of data, and then data checkpointing. So saving generated RDDs to distributed storage used when combining data from stream, long chains, and keep it reasonably small. All right, so what this is saying is we have two types of checkpoints. Checkpoints for the actual data and checkpoints for the metadata. Do we know what metadata is?
I was literally about to ask that, to be fair.
That's a good question. Any guesses? Shtiak, you can give me a good guess.
Okay. Metadata is, I'm guessing, the functions and methods that we're going to use on the actual data.
Not exactly. Let's see Google. What does Google say, guys?
It says
what is metadata? That's an important concept in the data engineering world.
So it's data about data.
Data about data. So what does that mean?
It's data about data.
What is
like
data about data?
So like a check, no, what's it? The checksum would be like kind of metadata in a way.
It'd be like a file type. A file type counts metadata.
Possibly, yeah. So metadata, it's actually a field on its own, concept on its own. It's the definition is data about data, but that's not very helpful. Actually, more confusing.
Actually, right? Like, what does that mean?
Well, what does that mean? So I'll give an example. It's like saying if we have a batch of data coming in, yeah, and you have like a log or a summary file that says, you know what, we're getting 5 files. The size of each file is 2 gigabytes. The extension is .txt, right?
Yeah.
This is information about the files. This is data about the data.
So I'll say, like, would a checksum of like a file be metadata in a way then?
I believe so.
Because it's basically saying,
it could be.
Yeah,
yes.
This is how big it should be.
Exactly. So storing metadata helps to understand our data. You can say like the first column would be the name, second column would be address, for example. That's the type of metadata.
Okay.
So that's why what it's saying here is you can store the actual data in a checkpoint or the metadata. Okay.
So, and could the metadata be used to kind of recreate it then?
I don't believe, no, I don't think you can recreate the entire metadata.
No, I mean, like, let's say the data is like just like a database data about the database. So would that information make it easier to be like, okay, this is what the database was about, and then let's say they could recreate their own version, which wouldn't be perfect, but it's like gives them an overview kind of thing.
It will give an overview. Hi, Kiki. You just joined us. How are you?
Yeah, I'm good.
Hi.
Welcome.
Sorry.
We're going through, hands-on session for Spark streaming. We're almost done, actually. So to answer your question, Tafadzwa, it would help us understand the data and the context of the data, but it will not recreate the entire data set for us, right?
Yeah.
That you need some more information, I believe.
More details.
More details. All right, so that's the idea about checkpoints. In some cases, we need to provide a directory for checkpointing. Okay, these are just some details. Always check that the docs of operations are applying on streams. Okay, procedures to follow when working with streams. So we have some steps to employ. This is kind of a summary, right? Define a Spark stream context from the Spark session context. We saw that in the code. Define the input sources by creating input D streams. That's what we tried to do with the other notebook, right?
And CISO.
Yeah.
Netcat, yeah. You can play around with that and explore it. And we try to get it working and let me know how it goes. Then we can also do some streaming computations by applying transformations and output operations. So we saw some examples of these transformations, for instance, like joins, right?
Oh, yeah.
You can start receiving data and process it using this command, spark streaming context.start. And we can either wait for it to be stopped manually or using error or giving it a termination time. Like we had 60 seconds, 180 seconds, etc. The processing can be manually stopped using .stop command. Okay. This is just a summary of how to work with streams applications. In addition, we should remember, especially when working with multiple streams, once a context has been started, no new streaming computation can be set up or added to it. So we can't change, basically, once you start, there's no modifications allowed, right?
Yeah.
And once the context has been stopped, it cannot be restarted. I'm not sure why that's the case, but it seems to be the case. Only one streaming context can be active in a JVM at the same time. I think this could be an issue that we had, that error, multi-threading.
Yeah.
Because
when I restarted the kernel, that went away. So I'm guessing that's
could be. So one thing we can try doing is you can comment out once we're done. When you're playing around getting that netcat command to work, you can comment out the multi-processing part of the streaming context.
Okay.
Okay. So stop streaming context also stops Spark context. So if we stop the streaming, it starts the main Spark one. To stop only streaming context, we have an optional parameter called stop Spark context. We can set it to false. This is just tweaking, right? Spark context can be reused to create multiple streaming contexts. So Spark context is part of Spark core, right? It's the master one, the main one. Streaming is a subset of Spark, or rather one of the modules.
Yeah.
So that's the hierarchy. So as long as the previous streaming context is stopped, before the next streaming context is okay.
Okay.
Anything else? I can't see below that. Is that it, or do we?
There's nothing else.
All right. So that brings us to the end of the Spark streaming notebook. I will stop recording now. I think we covered the basic concepts and we got most things to run.
Yeah.
So thank you for your attention. I will stop recording.